Hey guys, today we're going to start a new chapter on polynomials. So we're going to start with some basic information, and a lot of this you guys already have. You'll see mine's blank in just a minute. I'll put the filled in sheet up here because most of this you guys already have, like I said, on your notes. Polynomials can have one term called a monomial, two terms called a binomial, three terms called a trinomial, four or more terms called a polynomial. In order for you to have a polynomial, you cannot have a variable in the denominator, you cannot have a negative exponent, and you cannot have two variables multiplied together, like xy or ab. So here are some examples of polynomials. I don't think you have this on your notes, so make sure you get this down. 4x squared minus 3x plus 2 is a trinomial. 5 is a monomial. Y is a monomial. 4 minus y is a binomial. Those are all polynomials. Not polynomials, 2 plus 5 over x because of the x in the denominator, 3x to the negative 7 because of the negative exponent, and 6xy plus 1 because of the xy. Taking a look at the chart that you have here, again, this part is probably not filled in, so make sure you get a chance to do that. A constant is a number, like 9. It is a monomial. It has a degree of 0 because it has no variable, and its leading coefficient is itself. So whatever constant it is also its leading coefficient. A linear expression has an exponent of 1. That is the degree. This is a binomial, two terms, and the leading coefficient is 1 because it's the number in front of x. Quadratic has a degree of 2, highest exponent. 3x squared plus 4x minus 5 is a trinomial. Leading coefficient is the number in front of x squared, which is 3. Cubic function 4x cubed minus 6. This is a binomial. Degree is 3, highest exponent. Number in front of the degree is 4. So here's your definition. The degree of a polynomial in one variable is the greatest exponent of its variable. The leading coefficient is the coefficient of the term with the highest degree. At any point, feel free to pause your video and get down what you need. All right, let's look at example 1 together. State the degree and leading coefficient of each polynomial in one variable. If it is not a polynomial in one variable, explain why. I'm not sure if these actual expressions are in your notes or not. If not, please write those down before you get started with the example. Part A is 7x to the fourth plus 5x squared plus x minus 9. It is a polynomial. It has 4 terms. So the degree is 4, highest exponent. Leading coefficient is 7, number in front of the term with degree. Part B, 8x squared plus 3xy minus 2y squared is not a polynomial. Why is that? xy multiplied together. Part C, 7x to the sixth minus 4x cubed plus 1 over x, also not a polynomial. Why not? X in the denominator. And 1/2 x squared plus 2x cubed minus x to the fifth is a polynomial with a degree of 5 and a leading coefficient of -1. A polynomial equation used to represent a function is called a polynomial function. If you know an element in the domain of any polynomial function, you can find the corresponding range by substituting. Example 2. The function f of x represents the total number of hexagons in a honeycomb. Show that the polynomial function f of x equals 3x squared minus 3x plus 1 gives the total number of hexagons when x is 1, x is 2, and x is 3. So we're going to find f of 1, f of 2, and f of 3. And we're going to practice using our store key for those. So 1, store x, enter, type in your function, 3x squared minus 3x plus 1, and you get 1. 2, store x, 3x squared minus 3x plus 1, and you get 7. 3, store x, 3x squared minus 3x plus 1, and you get 19. And then the next question says, find the total number of hexagons in a honeycomb with 12 rings. So we're going to find f of 12. 12, store x, enter, 3x squared minus 3x plus 1, and you get 397. So that store key comes in handy. Now, the store key does not come in handy in a problem like number 3. The reason is because you don't have a number in here, you have a variable. So then you just have to show your substitution. So find p of a squared if p of x is x cubed plus 4x squared minus 5x. So p of a squared, everywhere you see an x, replace it with a squared. So a squared cubed plus 4 times a squared squared minus 5 times a squared. Raise to a power, multiply the exponents. Your answer, a to the 6th plus 4a to the 4th minus 5a squared. Taking a look at your next page, find q of a plus 1 minus 2 times q of a if q of x equals x squared plus 3x plus 4. So q of a plus 1 is a plus 1 squared plus 3 times a plus 1 plus 4. FOIL method, so that's a plus 1 times a plus 1, first, outer, inner, last, or fast FOIL, whichever one you prefer. Distribute, combine like terms, and you get a squared plus 5a plus 8. Q of a is just a squared plus 3a plus 4, and 2 times q of a is 2a squared plus 6a plus 8. So q of a plus 1 minus 2 times q of a, so minus 2a squared minus 6a minus 8 is negative a squared minus a. Now, I know that you have this information here written out for you on your notes. What you don't have are these graphs. So I need you to pause your video. I need you to draw the graphs and write the information. And then I need you to mark anywhere it crosses the x-axis. Now, these graphs don't have to be perfect. They do need to be fairly accurate. So like I said, pause your video, write those down. These graphs show the maximum number of times the graph of each type of polynomial may intersect the x-axis. The x-coordinate of the point at which the graph intersects the x-axis is called the zero of the function. And we've already talked about end behavior. The end behavior is the behavior of the graph as x approaches infinity or x approaches negative infinity. Now, the information that you see here at the bottom, I need for you to fit into the chart that you see on your notes. So for example, you have a degree column. Underneath it, I need you to put the word even. Beside leading coefficient, I need you to put positive. Beside end behavior, this is written kind of backwards, so I'm gonna write it out for you. As x approaches infinity, in fact, you can forget this part right here. I'm just gonna write it out for you because it looks very confusing. For this first graph, as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches infinity. And then I need you to draw your graph and label your function. So this is going to take you a couple minutes. You are going to need to pause your video, but I'm going to go ahead and do your end behavior for each one of these. In fact, I think I've already done it for this one. As x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity. So you don't need this part here. And as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches negative infinity. And again, you're filling in odd, positive, end behavior in the graph, and then write the function. Degree, leading coefficient, end behavior, graph, and function. And then for this last one, as x approaches infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. and you don't need this part here. All right, the last part is on even and odd. And again, you guys have already gotten this information down. It is at underneath where it says even versus odd. The graph of an even degree function may or may not intersect the x-axis depending on its location in the coordinate plane. If it intersects the x-axis in two places, the function has two real zeros. If it does not intersect the x-axis, the roots are imaginary and cannot be determined from the graph. If the graph touches the x-axis, there are two zeros that are the same number. The graph of an odd degree function always crosses the x-axis at least once, and thus always has at least one real zero. And now we're going to look at these last three examples here at the bottom. Again, your instructions are there. You're going to need to copy the graph. So take just a minute and do that. And we are going to find the end behavior, even or odd, and the number of real zeros. So for part A, as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches negative infinity. Both of them are going down. Determine whether it's odd or even. It touches two times, so it is even for two real zeros. Part B, as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity. It is an odd function because it touches one time. Part C, you can see the graph goes up on both ends. So as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches infinity. It is an even function because it doesn't cross the x-axis. This concludes the introductory material to polynomials. Let me know if you guys have any questions, and I hope you have a great day.